In the previous video, we discussed how to factor basically any trinomial in quadratic form. By that, I mean in this form here, ax squared plus bx plus c, so that we can deal with the leading coefficient not being 1. But if the leading coefficient is 1, there's a much easier way of doing this. And I realize most of you guys know how that works, and you can do it hopefully quickly without having to split the middle term. We're going to split the middle term for the first one just so you can understand why the quick method or the shortcut for this works. I may ask on a test or a quiz to explain why it works without having to go through all the steps. Basically, what we would be doing is looking for factors of the last term that add up and give me the middle term. And those two factors are going to be essentially the two numbers that we put in, for example, x minus n times x minus m. Those two factors, the m and the n, would be factors of the positive 6, for example. So why could we do it that fast way? Some people just know to do it. They just don't understand why. So going back to the previous video, we know that if we're doing it like based on its definition, essentially, of factoring, if the leading coefficient is 1 here, if we're using a times c, it's going to be 1 times 6. And we're trying to find factors of positive 6 that add up and give me negative 5. So that's split 1 and split 2. And that would be, I guess, negative 2 and negative 3. And we would split that middle term. And again, if I'll say this, you can put me on fast chipmunk speed. You don't have to listen to this slowly because I know you guys know this already. So now I'm splitting the middle term. But what I want you to notice, if the leading coefficient is 1, if you look at my first pairing, no matter what, the only thing I would be able to factor out would be x. Because that leading coefficient in front is 1, there's not going to be like another number that I can take out. I would need to have another number in front of this right there. But I don't have that. So no matter what, it's going to be x minus 2. And P.S., that minus 2 was one of the split numbers. Do you guys see the minus 2 here and the minus 2 here when I factor out only the x? Because that's the only thing that I can factor out. The minus 2 will stay there. The same in the second grouping here. I know that the second number in the split, negative 3, I could have switched to negative 3 and the negative 2, but I just chose it this way. The negative 3 will go into the positive 6 because I got the factor of negative 3 from the 6. So that, again, in this split, in this grouping, I can factor out a negative 3, and then I'm left with an x minus 2. If those two binomials don't match, I did something wrong. But look here, I get x minus 2 times x minus 3. So essentially, I get, it's x plus split 1 and x plus split 2. So if I just know the splits, the way to split the middle term here, I can just write it x plus whatever one is and x plus whatever the other one is. In this case, they both happen to be negative. So if I look at this here, if I multiply these two back together, I would get an x squared plus outer, it would be, I guess, split 2x, inner split 1x, and last s1, s2. If I factored out an x in the middle here, I get split 1 plus split 2, or you could do split 2 plus split 1, doesn't really matter. Addition is commutative. I'm factoring out the x out of these two because those are like terms, plus s1, s2. This is a product on the end, and this right here is the sum. And it's a sum of the split. I would split the middle term into if I ended up doing it the traditional way, right? So in this case, because the leading coefficient is 1, as soon as I find these two values right here, I can skip all the work and just write x plus the one split times x plus the other split. And this is why this works. It's because, look, this AC is actually really, because A is 1, I end up with just x squared plus bx plus c. I'm finding factors of c with some b, like that. And therefore, look, the factors of c that will add up and give me b will just be the two split values that where I multiplied them out here on the side. Okay, so the fast way then, because the leading coefficient is 1, I just need to find factors of negative 72. And again, if you're struggling to find them without a calculator and I don't give you a calculator for the test, be systematic about it. Okay, negative. First of all, it's a negative, so one of the values have to be positive and one of them has to be negative. Otherwise, they won't multiply and give me a negative number. 1 and 72. I then go to 2 and 36, just being, I'm not even close, right? Some people see it right away. That's great. If you don't, it's not the end of the world. You can always like approach it some other way. So 24, and we end up, in this case, we want a negative value in the middle. So I know the bigger number has to, or the bigger absolute value has to be negative. 4 and 18. 5 doesn't go. 6 and 12. 7 doesn't go, but 8 does. 8 and 9. Oh, here we go. 8 and 9 worked. So I don't have to do any work. I know it's going to be x plus 8, x minus 9. All right, pause the video and try the others, and I'll write down the answers now. The last one, part D, you just have to be careful. Remember step number 1 in factoring, you've got to take out the GCF. They all have an x, so I'm left with x squared plus 2x minus 35. Then I find factors of negative 35 that add up and give me positive 2. That would be positive 7 and negative 5, and I'm done. And don't forget that first factor out there. Okay, factoring with leading coefficient of 1 should take, as long as you can find the factors, that's how long it takes. That's the only thing that it takes. All right, the last little bit of factoring we're going to do today is temporary substitution. Now, temporary substitution can be used in many ways, but in this particular case, you're going to pick a variable not in the problem, then rewrite. We've done this before, by the way. The problem in terms of this variable. Often we can rewrite into a quadratic expression. Expression or something else that is easily factorable. Expression like that. Or something else easily factorable. Or something else that is easy to factor, or easier to factor. So for example, in this case here, and there's a nice little rule of thumb, and I'm going to put it up here. Well, actually, maybe I'll get rid of this mess here and say, instead, in your notes, maybe write the rule of thumb here. And it doesn't work for everything, right? But it's a lot of times it does. It's a rule of thumb. Draw my little thumb. R-O-T, rule of thumb. If you can double the exponent of one term and you get the variable with, I should say, with exponent of another term in the problem. It is a good candidate for temporary substitution. All right, so if I look at this problem over here, do you see, I'm going to highlight it instead, this guy right here. The exponent is n. If I doubled that exponent, it becomes 2n. I get the other term here. This is the perfect time to use temporary substitution to help me factor this. So what I'm going to do is pick a variable that's not in the problem. You can pick whatever, as long as it's not the same variable. In this case, I'm going to pick a. First thing in the alphabet, no other reason. And then I'm going to let it be x to the n. That's that middle, the smaller of the two exponents. That means a squared would then be x to the n raised to the second power. A power to a power you multiply, it becomes x to the 2n. So in this problem, I could rewrite it as a squared minus 5a plus 6, which is now just a regular quadratic. It's called quadratic form. It's in quadratic form because I can rewrite it as a quadratic expression. This I know how to factor. The factors of positive 6 that add up and give me negative 5 is negative 2 and 3, negative 2 and negative 3, a minus 2, a minus 3. But just remember, I don't want it in terms of a. A was x to the n, so I just substitute x to the n back in. Now, some people do this in their head, like the temporary substitution in their head, and they realize, oh, this would just factor where one term would have to be x to the n and the other would be x to the n. I'm okay with that as well. But I'm going to show you with temporary substitution because when we get into more complex problems, this will actually be really helpful. In the next one, again, if I doubled, see, I have x to the second power. If I doubled that exponent, it would be x to the fourth power. Yes, we are in a situation or scenario where we can do this. So I'm going to pick a again and let it be the smaller of the one with the smaller exponent. That means a squared is equal to x to the fourth. And no, you do not have to write this part. I'm just writing it out to explain it to you. So we have a squared, whoops, not plus, but minus 13a plus 36. And then we factor. Are there factors of 36 that add up and give me negative 13? I think it's negative 4 and negative 9. Okay, well, a was x squared. So x squared minus 4. I got to be careful because we want to factor completely. So when I substitute back in, I can see, difference of squares and difference of squares. Math teachers love this because you get multiple. This is like a 3-for-1 deal here. So I can factor further. X minus 2, x plus 2 is the one, and the other x minus 3, x plus 3. And now I know it's been factored completely. For the next one, you could expand. It creates a lot of work. But again, I'm seeing this. This is PR to the first power, and this is PR to the second power. I doubled the exponent of one, and I get the other. I'm going to make sure I pick a variable that's not in the problem. I pick a again here. Let that be p minus r. Or I said pr before, but I meant p minus r. So in this case, it's going to be a squared minus 8a minus 33. Factors of 33 that add up and give me negative 8 is a minus 11, a plus 3. And then substitute back in. A was p minus r minus 11, and p minus r plus 3. And I'm done. All right, the next one is a little bit tricky. Because if I look at this, yeah, if I tried to double this exponent, I wouldn't get this. But what I do notice is that I have an x in every term. So just take a deep breath for a second, step back, and look. I have an x in every term. That means my GCF is an actual x. So I'm going to factor that out. It's going to give me an x to the 2n plus 5x to the n, because I'm taking one x away from each of the terms, minus 14. And now it's ready to use just for the quadratic form inside here, a is equal to x to the n. So that gives me, x is still there, a squared plus 5a minus 14. And the factors of that are going to be plus 7, a minus 2 times x. And then remember, a was x to the n. So we substitute it back in. So this is how to deal with something that's not what looks like what we're used to. I swear I can talk like that. Sometimes I'm actually going to put another problem in here that's a little more interesting. Sometimes we have something that looks like this. Let's make it interesting. X to the 2n plus 4 minus 4y to the, let's say, 8n minus 6. For this one, what I notice, number one, it's the coefficient for y is 4. And also for the x and the y, they are multiples of 2. I could actually rewrite these both as like this. X to the n plus 2 squared minus 4 times y to the 4n minus 3 squared, like that, because 2 goes into both of these exponents. And then here I could let a equal x to the n plus 2. And I mean, my b's, I apologize in advance. Maybe I'll do a scripted, otherwise they look like an 8. No, they look like a 6, I mean. Y to the 4n minus 3. So that I could rewrite this as a squared minus 4b squared, which then factors as the difference of squares. So just keep an eye out for that. You know, is something, I can't use temporary substitution by doubling an exponent, but if it is a double of something, it might be helpful as well. So that's why I chose it. So a minus 2b, a plus 2b, and then we can substitute back in. So that would be x to the n plus 2 minus 2y to the 4n minus 3. And then the other one would be x to the n plus 2 plus 2y, 4x to the negative third. Oh, not x, n, sorry, n, like that. Okay, temporary substitution. That's about all we know for factoring so far.